Okay, so let's take a look at what you're going to be handing in for the second part here of module 1. So this is a good time, if you're not listening to me, to listen, okay? Because I'm going to be going over what is expected to hand in for the practice problems and for the assignment that pertains to chapter 4. So I'll wait till everybody's ready. If I don't have your eyes, then I'm not going to start talking. I have all night. All right, let's look at module 1B practice problems. I want to be sure that you know what to hand in for what we had gone over for chapter 4. So let's click on there. You're going to notice that the last time we were together, we went over examples 4.1 and 4.2. And then tonight we did 4.6, 7, and 11. Okay, so you're going to want to be sure that you hand these in as we had done them in class, because that's going to mimic how you're going to hand in similar homework problems for our assignments. Okay. Again, these are the practice problems. This is either a 0 or a 10. I allow 1 or 2 small things that you might miss, but beyond that, if you miss them, it's a 0 and there's no opportunity for any correcting. Okay. So make sure that you pay attention to those details. Also include in your document that you hand in 2 things that you learned and 2 things that you still feel like you need some additional practice on, because those are things that I'll, go over, if needed, or I'll write notes in the feedback to help you along with that. Notice down here, submitting instructions. You have to use AutoCAD for all of your kinematic diagrams. Make sure to add all the link and joint labels. In some cases, when we moved things around, we didn't move all of the labels. Make sure you kind of understand and know where those are. And I've been talking them through for each one of our examples. Also show your mobility equation for each one. And then depending on the mobility equation, you can either put it as part of the AutoCAD file, or if you do it on the side by hand, then you'll have to scan that and add that as well. Okay. So that's the practice problems. Any questions on those? And we've gone over each one of these during our lecture. So if you do need to go back, I'll have the recordings up after class today. Let's look at assignment number 1, part 2. Now, it does look like a lot here, but truly it's 3 kinematic diagrams. All right. So let's look at the end of the chapter. We've already briefly looked at these the last time you kind of started on it, but it's worth going over again. So I'm going to go underneath the camera here. Okay, so the first 2 that we have, this is on page 101, second column, 4.5. You're going to graphically position the links of the compressor exactly the way you see them in this illustration right here. And then you're going to reposition the links so that the 45mm crank is rotated 90 degrees from where it's at, not to a 90-degree position. So do not put it going straight up. You're going to go 90 degrees from where it's at right now. So it'll be technically 120 degrees from where it's at. Okay. Counterclockwise. And then determine the resulting displacement of the piston. So this is going to be, if you would, its home position. It's going to pull back. And now this is going to be the new position. And you want to add the dimension for that. Okay. That's problem number 4.5. Then for number 4.6, you're going to use that very same illustration. Do not do it all on the same one. So have problem 4.5 with its 2 positions, and then just copy the original that you had here for 4.5. And then now you're going to do the repositioning as it says here for 4.6. Josh. You can do them in the same file, but your screenshots will be separate for me, because otherwise it would be too cluttered. Does that make sense? I don't want to have 3 and 4 of these on there. Is that okay? All right. So, but yeah, you are, and it's easy to copy and paste them inside of the same file. That's totally fine. So what Josh was asking is, can I put both of these in the same file? Sure. I don't care how you file manage them, because I just want the screenshots. Okay. All right. Then as we turn the page, we've got 4.7 and 4.8. Similar thing. You're going to draw the kinematic diagram for what you see here, and then you're going to reposition based on the description for each one of these. Okay. And then your third one is going to be the rock crushing mechanism. Okay. And here again, this is your like home position, if you would, and then you're going to reposition based on what's there. Now, something I am going to expect I'm going to see is that when they're asking for the resulting displacement of the blade, for instance, this blade is going to be it's going to be shown as a slider, which is going to mean that you get a linear displacement. So you're going to show a linear dimension for whatever that difference is. But on this one, your resulting output is actually going to be a rotating link. So it's going to be an angular displacement. Do not go to the endpoints, for instance, and show, oops. Let me open up one that we did, one of the examples. I think it was 4-7. So something that I see commonly happen is when we have an angular displacement, sometimes students forget, oh, I got to put an angular dimension here. Do not put a linear dimension on this. Don't go from that endpoint to that endpoint and just show a line like that. That is wrong. That is not an angular displacement. You have to show an angle dimension. So that's why on these, it's going to be an angle output. And on the slider ones, it's going to be a linear actual dimension. Does that make sense to everybody? So watch that for what they're asking. Is it an angle or is it a linear? Okay. So those are we had already kind of said that you would have been prepared. So if you got started on those, awesome. Great. So those are those. Then we're going to turn the page, couple pages, and we're going to go to page 106. Kind of in the middle here on that second column. Number 56 says you want to use that figure 4-5, which was the first kinematic diagram that you used. Okay, the piston, the compressor piston arrangement. And now you want to show the limiting positions. So the furthest point out and the closest point in. So if we go back those couple pages, this right here, this is an inline slider. You're going to show this laying all the way down and then going all the way here. And then you're going to dimension the stroke. Okay. You're going to do that very same thing for the next problem for this shearing mechanism. You're going to show it in its furthest point down and its furthest point up. And then for the rock crusher, you're going to show this so that it's rotated all the way forward and all the way back. All right. And then this is going to be an angular displacement, and it's going to be the full throw as we had called it. So not the stroke, but the throw. Okay. So that's going to be the next three problems. So again, using and building on those original kinematic diagrams. You don't have to do anything new. We're just working with those three. And then the last problem that you're going to do is just going to be 470, not 471, just 470. You're going to create the displacement diagram using Excel, okay, putting in the information, but then you are going to be showing graphically the crank moved to the following degrees: 30, 60, 90, 120, and 180. Okay, so there's 6 positions that you're going to show that last one in. Okay, this is going to be for the first diagram that you did. So it's going to be for this inline slider mechanism right here. And basically what you're proving is that how you're generating the displacements from, if you would, top dead center, if you choose that to be your first extreme position, you're proving that those are going to be the same values that you see as the displacements on your Excel diagram. So you would take a screenshot, you know, of something similar, but probably different orientation to this right here. So when we did these multiple movements on the same diagram, you don't have to put C prime, C prime prime, C prime prime prime, you know, all that kind of stuff, because it's just going to get too cluttered. Just make sure that you change colors so that you can see the different values, and then show me the measurements that you're getting from top dead center, which yours would be probably horizontally oriented. And then you want to include the spreadsheet so that I can see that, you know, your values match up with what you got here. And that's your check. This is your answer key, if you would. So you're going to put in the L2 and the L3 based on those values, and then you'll know if you have it drawn correctly or not. Now, additionally, I do have on the assignment an answer key, okay, for the above ones. So if we look here, you're going to notice that we have the answer key. Now you've got to show the work for these and show the dimensions in place, but at least you'll know if you have the right values or not. Now I do have one. Last year I did have them do 71, but as I was looking at this, it's enough work with what we've got there. So I took 71 off. So you don't have to do 71. The assignment just has you go to 70. Okay. So, and again, I think that's plenty for what we're working on. So any questions on assignment 1, part 2? Okay. Then the rest of the time that we have together, I'll be here to answer any questions you have. I think it's about 2 hours-ish, right? Yeah. Yeah. About 2 hours. I think, 8:50, right? 8:50 at the end of class. So you'll have the rest of the time to work on, getting started on this. If you have any of the first assignments from this module to do, that should be your priority, but then, and then work to the second assignments here that pertain to chapter 4, you know, as you're able to. Okay. So I am going to stop the recording.